In this video, we'll be discussing Introduction to Relations and Functions. So there are four representations of relations and functions. First is a numerical representation, which is like a table or a list. A verbal, which is like a word description, something you might say like a word problem. And there's also symbolic, which is given by an equation like x is equal to y. And graphical, which is you're presented with a graph. And so you're going to be able to determine if a relationship is a function, and if it is, justify why, along with talk about the function's domain and range. Additionally, we'll be building up concepts about how to graph functions, given a symbolic or verbal description, and getting into the basic ideas of building linear models from verbal descriptions. To get us started, a relation is any set of ordered pairs. So like for instance, using a set theory, for example, we have the ordered pairs of like 1, 2, 2, 3, and 3, 4. This is an example of a relation. And some things to think about this is that what this is saying is that we're relating 1 to the value 2, 2 to the value 3, 3 to the value 4. This is kind of a simplistic view, and it kind of misses some of the ideas what a relation actually says. A relation is actually telling you is that we're associating the value of 1 to the value of 2. So that means if I give you a 1, you will then tell me 2. So if I say 2, you say 3. That is what the relation says. I give you a value, and you tell me another value. You may tell me a few values, but that's completely okay. Another example with this set of ordered pairs idea, we have, say, 1, 2, 1, 3, and let's say like a 2, 4. It's a variation on the first one. This is still a relation, but what has changed? If I say 1, what do you say? You say, well, if I say 1, I'm going to say 1 is there, okay? So you're going to say 2. But if I say 1, there's a second 1 in this one. So you will also say 3. So you have two choices here. So if I say 1, you say 2 or 3. Well, in fact, 2 and 3. So this is a feature of relations in that it's a bit unstructured, in that if I say something, what you want is to say one other thing back. So like if I say 2, you will only want to be able to say one thing, the number 3. So the basic idea here is that a relation relates to values, an input to an output. And the input here can be repeated. In another example of a relationship, say we have a list of people In another example of a relation, say we have a list of people and tasks. So let's label the people. I'll go with Alice, Bob, and not Bod, and Carol. And let's say we have several tasks. One could be doing data analysis. Another one could be constructing graphs. Another one could be making a presentation. And let's say there's another one which could actually be doing the presentation. And so for each of these people, say you're a manager, you have this team, Alice, Bob, and Carol, and you have 4 tasks. And you're like, okay, we need to get all of these tasks done. So what you're going to do is start to assign people to a task. So say Alice is really good at data analysis. So you're going to assign her to data analysis. Let's say Bob is really great at constructing graphs and doing presentations. So we're going to assign him to both of those tasks. And then Carol, she's got a really great personality, so she's going to do the presentation for the group. So here I assigned each person a task to do. And in fact, here the thing to notice that I assigned Bob 2 tasks. So Bob gets 2 tasks. Alice gets 1 task. And Carol gets 1 task. So to note, each person gets a task. Even though each person gets a task, Bob gets 2 tasks. This is an example of a relationship, but it sort of also demonstrates that there's an issue going on here. Bob is not going to be happy with getting twice as much work as another person. So that issue with Bob being a little bit unhappy with that twice work goes into the idea of a function. Now let's revisit the first couple examples when we talk about a function. So we're going to find a function as a relation. So this is a smaller class of relations, which for each distinct value in the first component of the ordered pairs, there's exactly 1 value in the second. So I want to emphasize that there is exactly 1 value in the second. So if I say, for instance, in this first relation, if I say 1, you say 2. All right, so if I say 1, you will distinctly say 2. All right, if I say 2, you will say 3. So if I say 2, you say 3. And again, if I say 3, you'll say 4. There is no issues with multiple outputs. All right, so there's no issues with multiple outputs. There is exactly 1 value in the second component for each value in the first component. So in this case here, this relationship is a function. There is no ambiguity as to which output we're going to select. Now, if we take a look at the second relationship down here, we noticed before that if I say 1, you say both 2 and 3. There's an issue. All right? There's an ambiguity. That ambiguity means that this is not a function. All right? There is 2 outputs for 1 input. All right? So think about this. For a function, we want 1 output per unique input. There should be no ambiguity in what that response should be. Think of this as an input-output model, which goes into the idea of a function notation, which we'll be discussing in the next lesson. Now, revisiting this problem of assigning people to tasks, the issue before was that we had Bob going to both constructing graphs and presentation. All right, Bob wasn't happy with that. The reason Bob wasn't happy with that was, in fact, our assigning people to their tasks was not a function. Right. So you can go back and view that part of the video again as to why it's not a function. But the issue is Bob had 2 tasks, even though everyone else had 1. So to fix that, what I'm going to do is still assign Alice to data analysis and Carol to doing the presentation, but I'm going to assign Bob to only constructing the graphs. So that means that there's this issue now, is that there's no one to do the presentation, but unfortunately it's going to have to fall to you, the manager. Because to be fair and to make this into a function, into a more balanced, the relation into a more balanced function, we're going to have to assign each person to a single task at first. Maybe Bob does a great job and constructs those graphs really quickly. Then you can sequentially assign them to a presentation, but for this to be a function, Bob can only do one thing. That is the lesson here. You don't want to overwork people. Functions are relations that for each output, you only get 1 input. So if you think about this, if you assign 2 tasks to one person, that is a relation, but not a function. If you assign 1 task to one person, so if I'm like, Alice, you're doing this, Alice will be like, okay. But if you're like, Bob, you're doing these 2 things, and Bob goes like, which one do you want me to do first? Then you can see that that is a relation, not a function. So that leads us into another example. Which relation is a function? So I have 2 here. The first one I give you in terms of a table, it's the list. I just want to point out that these represent ordered pairs. So in this case here, this can be represented as an ordered pair as 0, 1. This one could be as 1, 0, 2, 1, and 3, 0. So a table is just another way of writing an ordered pair. That's just something to keep in your mind. So taking a look at this one here, for each input, so these are your inputs, you have an output. And so looking at this, each input gets assigned to one output. So this one is a function. Because each input gets assigned to one output. Now, outputs are repeated. That is completely okay. So repeat outputs is okay. But repeated inputs is not. You can't have one input going to several different outputs. Now taking a look at the second one, this one is defined as an equation. The x values, which again are our inputs, and our y values are our outputs. So what this relation is saying is that our input has to equal to whatever our output is squared. So for instance, a simple one might be 0. If I put in 0, that means that our x is equal to 0. That is equal to y squared. So that implies y is equal to 0. So then we have our ordered pair associated with thing 0, 0. That's completely fine. What if we plug in a value of 1? So if I put into our x coordinate 1, well, 1 is equal to y squared. Well, thinking about this, what y values could work here? So I'm going to try y is equal to 1. Well, in this case here, we have 1 is equal to 1 squared. That is okay. So we get one value as being 1 there. But are there other things that square to 1? So let's try, how about this? Y is equal to -1. So I'll be honest with you, this requires a little bit of playing around if you're not used to playing around with numbers like this. That's completely okay. Just take your time. So here you have 1 is equal to -1 squared. That still works. -1 squared, so -1 times -1 is in fact +1. So we have a second point, 1, -1. So this one is not a function. So it's not a function. And real quick, why graphically, and so later on this lesson we'll learn the vertical line test, is that if I were to graph this graph looks like this. And so if this is our x and this is our y, what I'm saying here is that the value 1, so if this is 1, we have 2 outputs here, +1 and -1. So there's an ambiguity with our input and then our output.